speakers. About Kubernetes and why it's switching. Okay. The second one is we're gonna have Zidan, so he's gonna come up. He's gonna come and speak to you guys about EKS upgrades and how it works on the infrastructure and all that. Okay. And the last one would be from Shah Hassan. So he'll be telling us about some tips and tricks from containers to multi-regions and all the different security stuff. Okay. So we will go next. All right, so this is the agenda for today. So from 6, I know we are running out of time a little bit. Okay, we just overshot the time a little bit. All right, so at 7:05 we will have Amit. All right, then we'll have 7:45 onwards. We'll have a quick transition break, about 5 minutes, and then we will also have a TS. After that, we'll have Zidan, and then lastly we'll have TS Shah Hassan. Okay, and of course we'll close everything up with a Kahoot quiz. I'm sure many of you guys are interested in the Kahoot quiz. Okay, but you guys should also show the same interest in our talks. Okay, because the Kahoot quiz is all about you listening to the talks. Okay, it's going to be that hard, right? Doing a breakdance. So SRE Kuala Lumpur. All right. So I will call upon Zidan, okay, to give you guys some introduction about SRE Kuala Lumpur. It will be a very short one because that is how it is.
Hi guys, thank you for being here. So, as most of you know, SRE is kind of initiated. Folks actually responsible about this. They are doing an amazing job, but we couldn't achieve anything without all of you. On the floor for all of you. Yeah, thank you for Xsolla. Xsolla is hosting us. Thank you for Ahmed from Class AI. All these beautiful tools and amazing things from Ahmed. Thank you so much. Thank you so much. Yeah, I'll not take more time. I'm about to repeat. Thank you guys.
Okay, cool. All right, next. All right, so a little bit short introduction about Docker Kuala Lumpur. So Docker Kuala Lumpur is actually being supported by Docker United States itself. So we are basically like a chapter within Malaysia. All right, so whatever we do is endorsed by. Right, and the first one is that this community is open for all of you guys. Either you are a student, engineer, architect, not the building architect, but maybe a solutions architect and all that. Yeah, so we are open for all of us. All right, and then the second one is that we basically focus on DevOps, container learning initiatives, and everything. Sooner or later, we will probably the next meetup we will have our first workshop in Malaysia. Okay, we're gonna have basically an event, a meetup. Basically, it will be more like a workshop team. The third one would be it basically connect all of you guys, like either you are a beginner, or professional, and all that to the industry itself. So it's easy for you guys to learn, collaborate, and make friends, maybe. All right. And if your company is good enough, or if they have the enough capacity in terms of money, they can get a Docker Swarm license from us. All right. Number 4 is that we share practical knowledge. So this one can be anything, right? As a captain, myself, I'm a Docker captain for Malaysia. So there are only 3 captains in Malaysia. All right, throughout the entire Malaysia. Yeah? So what happens is that we share technical knowledge across Malaysia, and at the same time we give out swags. So if you join our meetups, our events, get swags. Okay, directly coming in from the US. I'm not sure about now because of all that closure and all that, but then yeah. Number 5 is that we support local talent. So if you are a person in Malaysia, or basically anyone within Malaysia, if you guys want to give a talk about any of the topics, reach out to us, come and give a talk, you'll get something back at the end. All right, and the last one is that we are, as always, we are supported by Docker Incorporate. And yeah, as on behalf of Docker, we would like to thank you guys for joining. Okay, thank you guys. All right, so sponsor highlights. So this one, Zidan has covered a little bit. So this one basically would be me thanking Xsolla for having us today. Please give a round of applause to Xsolla. And Cast AI. Cast AI gives good food. Okay, I'm sure many of you guys are full now. If you guys not enough, you guys can return to Cast AI. Okay, but other than that, yeah, we hope you guys had some good food, good meals and all that. All right, we don't have passport. All right, so we will go to our first talk. So let's call upon Amit. So Amit is the director of solutions engineering at Cast AI. So he'll be giving a talk about intelligent and automated Kubernetes management. Listen to this carefully. Okay, because the surprise is at the end.
Share the screen. Yeah, just have to share the screen.
Cool.
Yes. And we share with you all the same thing.
You guys look a bit sad.
Okay. Books. Long sleeve.
Food?
Not
enough food?
Oh, she have to be.
It's like putting me in a gunpoint. All right, let's call upon Amit. Please give a round of applause.
Thank you. Good evening, everyone. I'm Amit Pahwa. I work for Cast AI. Before anything else, I'm a DevOps engineer, a solution engineer, an SRE, one among you. I know people get very sleepy after dinner. We can't have coffee now after dinner, so I have two ways to wake people up. First one, fear. Second one, reward. Fear, AI. Reward, AirPods. So at the end of this quiz, in this presentation, we have a quiz. The fastest to answer highest number of questions right takes away AirPods 4 as the prize. And they are original. I didn't buy them from the China now, I promise. Now coming to fear. We all know AI is impacting our lives, our jobs, our productivity. Now, what are the roles that are getting impacted? I pulled out, in fact, I asked ChatGPT to generate a list for me of 100 jobs that will disappear because of AI. Too tiny to read, but this is data and admin, customer facing, call center agents, writing and content creation jobs. Luckily, we are none of them. Where are we? Which section? Right here. IT and software. QA engineers, testers, entry-level software engineers, junior software engineers is a role that will disappear because of AI. That's the fear. But do we live in fear? No. There are 100 jobs that will benefit from AI. There are 100 roles, different jobs that may get double the salaries, double the jobs. What are those? Those are the areas we want to be in, right? Those are software engineering at the number one. But if you notice, the number one, you can't read, I'll send this deck to all of you, but it says senior software engineer. So the junior software engineers gonna go away, the role's gonna go away, and the companies need senior software engineers. It's like, you can't be a dad because you have never been a dad before. Right? If you have to be a senior software engineer, some point in time you have to start as an intern or start as an engineer. That's the conventional thought. But how our careers are going to change over the next few years is that a junior software engineer who uses AI is going to become the senior software engineer. Right? AI is not replacing humans. Humans are smart, but humans with AI are smarter. So I was not actually mongering fear, but encouraging all of you, including me, including myself, that we need to use more AI. More AI, not just to generate email content, not to just answer our questions through an LLM, but also to manage infrastructure, do your day-to-day DevOps, SRE, software development tasks using AI. Now, you must be wondering, this guy comes to stage, talks all about how AI is impacting their lives, jobs, careers, but what does Cast AI do? How can Cast AI, my company, help you achieve, become smarter humans, smarter SREs, smarter DevOps engineers and DevOps architects? Is simply by making sure that we automate our tasks using AI. We automate our day-to-day tasks. We optimize our company's infrastructure. When I say infrastructure, it means CPU, it means memory, it means servers, it means storage, it means network using AI. And that's precisely what Cast AI, the company I represent, does. In the world of AI, machines are expensive. When I say machines, it means virtual machines, it means servers, and the cost is typically 4 cents per CPU per hour. Sounds tiny, but when you multiply it by number of hours in a month, number of hours in a year, it adds up a lot. Any money you save for your companies is gonna eventually come back to your own pockets as salary increases, as promotions, and as your company money, right? This is about CPU. CPU is expensive, but when we talk of AI, we cannot talk of GPUs. GPUs are even more expensive. Can someone do a quick calculation? 4 cents per hour to $12 per hour. So it's like 24 into 12, 300 times more expensive, 350 times more expensive than CPU. So in case your company is currently using GPUs or plans to use GPUs, you better pay attention for next 15 minutes because you can save tons of money, tons of cloud expenditure for your companies, for your organizations, for your teams. The base of any application running in public cloud these days is Kubernetes. If you are using Amazon as a cloud, it's called EKS, Elastic Kubernetes Services. If you're using Microsoft Azure, it's going to be AKS, or if you are using Google, then Google Cloud, Google Kubernetes Engine, GKE, or any other 3-letter acronym that actually represents Kubernetes running in the cloud. That's what I'm focusing on today. How to run Kubernetes using Cast AI to be more efficient, save highest cost, and at the same time, let your applications be highly performant and stable. And remember, everything I cover in this presentation today, 90% of that is the scope of questions in the quiz as well, right? So this is how we expect that when we start using Kubernetes or when we start using containers, it looks like a game of Tetris. This is what we expect, that every time a new container comes in, it's perfectly bin packed. Bin packing is nothing but packing your containers, your pods into lower number of machines. This is what we expect containerization to look like, but this is what reality is. The resource utilization in Kubernetes is ultra low, and this is why this game of Tetris is never efficient. That's why you need a tool that can automate these things for you. As your organization's applications grow from stateful to microservices to real-time data pipeline and now to AI models and GPU workloads, your workload is increasing. But is any company adding as many people in the DevOps team? No. I meet hundreds of DevOps engineers, architects every week. And when I ask them their workload has doubled, but not their team size. Their application, their users have doubled over the last 5 years, but not their team sizes. That's another reason you should be using AI to increase your productivity and hence reduce the cost. Now, this is a question I always ask the room. You all use cloud? Anyone who uses cloud in this room? Any form of cloud? Most of you, right? This is, if I ask any of you 101, how much of cloud you actually use? If you pay $100 every month, what is your actual utilization?
Here. Is it the biggest one?
Yeah, 30. Any other number?
Alright.
10%? You're very close. So Cast AI does the annual survey of what is the average utilization of CPUs across the industry. You know what was the number for last year? Somewhere between 10 to 20%. If you're keen to know the exact number, go to cast.ai and you can find a report there called Kubernetes benchmarking report. We publish this report every year. This number is just between 10 to 10%, 10 to 20% every year. So while we all complain that cloud costs are going out of the budget, there is still so much of scope to optimize. This is a reality. What we really use is 10 to 20%. This is the customer example. I onboarded this particular account, cloud account, to our dashboard. This is the utilization, the faint green line here. And this is what the customer is paying for. They're paying for 1,600 CPUs. An average CPU in cloud cost $20 per month. That's an average across the clouds. $20 per month per CPU. Multiply that by 1,600. It's going to be beyond the budget, and they use less than 100. Maximum usage is only 13%. Even worse for GPUs, 5%. CPUs is somewhere between 10 to 20, and GPUs is just 5%. GPUs are 300 times more expensive. So what is Cast AI doing about it? Time check, guys. How much time do I have? 20 minutes. Perfect. So we trained an AI agent who lives within your clusters. This AI agent lives within your clusters, and it is obsessed with efficiency. If you know Kubernetes, there are two primary components. One are your workloads, the pods, the deployments, the stateful sets, the daemon sets, which the developers specify how much their resources they need on. As a developer, all I care for that on a Friday night, I should not get a call saying your application is not working. I will go ahead, write 100 lines of code and say my application needs 16 CPU to run. Then it is a job of an SRE to do performance benchmarking to make sure 16 CPUs are not being wasted. How often can you do with your given workloads? The DevOps engineers in this room, the SRE engineers in this room, how much of a performance benchmarking can you do practically? Once in a quarter? That's a maximum. Average is once in a year. You can reduce that 16 to 4, maybe 5, maybe 2, but that's not consistent throughout the year. Your workload changes throughout the year. That code of application, 100 lines code, may need 16 CPU on a Monday morning, but may need only half a CPU on a weekend. Now, this agent that we have developed works like that SRE who lives within the cluster, optimizes the cluster 24/7 every 15 seconds. It looks at the utilization, it looks at the allocation, the request, and adjusts them to be as close to each other as possible. Here's the outcome. This is what you need. This is what you are paying. The gap between the two is the yacht Mr. Jeff Bezos bought last year. And when you run Cast AI agent, this is what happens. The two lines come closer to each other and save your team, your company, dollars that can come back to your bank account. Hopefully. This is an example of a large financial organization, one of the trading companies, one of the trading platforms. People wake up 9 a.m., the utilization goes up. At 9 a.m., people start trading. This is the utilization. This is what the developers are requesting for. And this blue line is what is being paid to the cloud provider, AWS or Azure. Now, what we do here is, the moment Cast AI walks in, we drop it by 50%. And we have not reduced the utilization. The utilization numbers are still the same. All we do is remove the wastage. So it's an agent that lives within the cluster. It's an engineer which is watching your cluster all the time, not taking lunch breaks, not taking any vacation, just working 24 cross 7 every 15 seconds to right size the cluster. What's the impact on cost? This particular customer was paying $750 every day, and they drop it down to what? About $30 a day, $40 a day. That's common. It's not surprising when customers go from $700-800 to $100 or $200 a day. We do this day in, day out. All you need is to be open to change, open to using AI, using a tool to make your lives easier. Instead of you manually doing this exercise of finding out what are my requests, what are my utilization levels, what is the provisioning, you leave it to an AI agent to do it for you 24/7. Overall, in our portfolio, this is all in terms of our offerings. You may be sitting in one of these teams, from developers to DevOps to SRE to MLOps, maybe working on any of the clouds or even on-prem infrastructure, any Kubernetes, any form of Kubernetes that I talked to you about. We optimize Kubernetes clusters the same way that I just spoke. We optimize databases and storage. If you use Postgres, you use Cloud SQL, MySQL, we optimize it the same way that I just talked about Kubernetes. Inferencing, which is to do with GPUs. If you use GPUs and they are not available in your current public cloud, or they are expensive, we take you to lower cost GPUs for those inferencing jobs. We automatically find what are the most optimal GPUs anywhere in the world which are available for you to run your application or inferencing workload on. We find those GPUs, make it a part of your cluster, use it, discard it, you pay only when you use it, wherever it is available at a lowest cost. And lastly, Omni is precisely the solution to do GPU management, LLM management. If any of your organizations have an initiative to adopt multiple LLMs, OpenAI, Grok, Olama, and then you need a layer of governance to make sure your costs are not shooting the budget, it is secure, and you need a cost and governance control over multiple LLMs. We have this solution called Inferencing in Omni, which lets you do precisely that. Just to summarize, there are a few things we do. First one, show you performance, cost, and resource utilization numbers. If you have a Kubernetes cluster, go to cast.ai or sign up at console.cast.ai. Connect your cluster. You would see a lot of data that your cloud provider doesn't show you today. What am I paying for? What am I actually using? In a read-only connect, you get that layer of observability. Second, you manage performance. Like I mentioned before, if a developer has requested lower number of resources than what your application actually needs, we right-size those as well. Next one being reliability, ensuring that your application, your end users get the resources that they always need. And lastly, the most important thing, automated operations, so that you can relax a bit, focus on doing more constructive work in your roles rather than firefighting. This automation is precisely what lets you have that automation of DevOps and SRE tasks that are very boring to do. Right? If you are keen to explore more, understand more, or just talk Kubernetes, it's me here, Amit Pahwa. I'll be at the back, and I have my lovely colleague Komal here, and come talk to us about any of these products. Or if you have a generic question about Kubernetes, DevOps, SRE, this is what we do for a living. And I do have a quiz. If I move to the next slide, you would see a QR code for the quiz. But let's do this first. This is my LinkedIn. If you wish to scan, connect, write a note, or ever, if you're ever visiting Singapore, want to have a coffee with someone, just ping me, please. Yep. Hand it over to the next speaker, please, before we come back for the quiz in next 30 to 40 minutes. Any questions, please? Yes.
So, from what
Praveen, can I have the microphone, please, for question?
Okay, right. Is still the meeting? Is it?
Yeah.
Hi, I'm Kwang from Hitachi Works. So my question is, from what I know, it's a Kubernetes agent, right? So it runs within the cluster. So my question is, how does it pair or how does it run in an air-gapped environment?
Okay. Short answer: we currently do not have an air gap solution, but if your infra is sizable enough, we are happy to build one. Yeah.
So far, you talk about CPU. We run a lot of Java programs, so the pain is always the memory. So can you move the workloads to the correct memory without the JVM starting its whole process again?
Amazing. Thanks for that question. That's a great question. The question here was, we use JVM-based applications and memory is a pain with JVM applications. First advice, move over from JVM. That's the first suggestion. But having said that, we do two things. Number one, JVM applications have a trait that when they start up, they consume a lot of resources. And after that, they settle down. So what we can do is, for right sizing, we ignore first few minutes. That's a configurable parameter. You can ignore that when this workload comes up, ignore first 10 minutes. Give it all the resources it wants. And from the 11th minute onwards, optimize it. That's one. Solution number two is that we understand your JVM heap sizes and we allocate memory accordingly and manage JVM workloads natively in our platform. So we can manage both JVM memory and CPU as well. That's right. So we read your container heap parameters and then accordingly right size your application's memory requirement. More than happy to set up a detailed demo. Yes, please.
My name is Ryan, and my question is actually, because you showed these graphs, right? And so you've got, it's plotted over a week and you've got your usage. Now, what I'm wondering is how long it takes you to effectively predict what you should be going and allocating ahead of time, right? Because there's going and handling it in the moment, but ideally you need to go and have it a little bit ahead, right? So like, what kind of lead time do you take to really go and get those returns that you're finding?
Okay, so the question here is, correct me if I do not rephrase it correctly. How long does it take us to right size your infra?
Correct.
Correct. Right. And I'll add another part to this question. If there's a spike, if I reduce 16 CPU down to half a CPU, and tomorrow morning there's a sudden spike because a concert is happening or there's a big sale on one of the local websites, yes, right? How we respond to those spikes and those right sizing is within 15 minutes. That's a long window. That's a long, unbearable window. So what we do is, by default, by the design, we read your matrix, do the right sizing every 15 minutes, but whenever we detect a spike is when I have one CPU allocated and you need more than 1.1, a difference of 100 millicore. Same way on memory, if it's 2 GB of memory, but you need more than 2.1 GB of memory, we see that as a spike. If there's a spike in utilization, we shrink this window down to 15 seconds. So we start right sizing your workloads every 15 seconds, which means 240 times every hour. We can right size your workloads to match the performance requirement.
Thank you.
Good. Any other questions, folks? Yes, please.
StreamYard.
Hi. So
Share your
basically,
screen.
for all cloud providers, they already have like some kind of like auto scaling.
Yeah.
That's good.
You just have to share your screen only.
If
That's it.
you put the
After you're ready, I'm gonna just
necessary
switch.
or the correct like range, usually it will be within that range, like 30 or 60%.
Mhm.
Yeah, maybe there is a possibility that you run at 40% most of the time, but you're scaling at 60. So that's where the waste essentially is. But how much does the auto scaling itself differs from whatever that you are doing? So what is the buffers that you put there?
That's a great question. Thank you for that. Yes, cloud providers, most of them do have their own auto scaling available, especially on the node level. There is Carpenter, there is Cluster Autoscaler, Azure has something, Azure also has auto mode, something like that. Yes, they do have a solution, but most of these solutions work on a static parameter like CPU. CPU touches 70% scale out more nodes. CPU touches 70% scale out more pods, HPA. What we rather do is number one, driven by policy, rather than looking at one parameter, look at pending pods, look at the behavior trend. Is your application spiking every Monday morning? Then also apply policies to it that this is a non-critical workload, go aggressive with optimization. This one's a critical workload, go very conservative. So you can apply all those policies and tons of other benefits. More than happy to talk about it more in detail. Okay, one last question, please.
The question is about the on-prem. So services beyond monitoring you provide for on-prem. Because my understanding is that the memory is the CPU is the whole, everything has been purchased. And
That's right.
Yeah. So,
Oh, you did. So the question here is, what about on-prem? When you remove servers from cloud, you stop paying for them. But on-prem servers you've already purchased, they're racked and stacked. What do you do with those? How do we operate, first of all? What do we do is we right size only the workloads. We do not switch off your machines. If you are running VMs from vCenter or VMware's ESX, we would mark these machines available for deletion. What we do is we right size all your workloads. If you were requesting 500 CPUs and we shrink it down to 300, then we shrink the pods, we do the bin packing that I talked about, we reduce the number of machines, that generates 10 free machines. We mark them as deletable or cordoned, or we can put a label on them, and then you can run your scripts to remove those machines and use them for other projects or use them for growth or any of those organization goals. So idea is, instead of using 100 machines at 30% utilization, use 50 machines at 60-70% utilization. And we can do that on-prem. Folks, I'm out of time, but available at the back along with my colleague here. If you have any questions, please come over and chat after the other speakers. Thank you so much.
Hope you guys have learned something today after the first talk. Make sure that you guys have taken note as well, because it's useful for us later. All right, so without further ado, let's call upon the second speaker. So the next speaker is going to be Ahmed Zidan. So it's going to be quite fun as well. Make sure you guys also take it. Not just the first speaker. All right, you guys sleepy?
Zidan is not sharing. Zidan, share your screen. Zidan.
Hello. It's a very tired day, and we are feeling sleepy, but we can do it. Hi guys. Good evening. Good evening.
Good evening.
Okay, so my name is Dan. I'm a site reliability engineer. Today we're gonna go through the ETS upgrade to prevent production failures at every step. Anybody using ETS today? 1, 2, 3. Okay, so for who? Anybody using Kubernetes today?
Anybody using Kubernetes, of course.
Okay, the topic would be kind of visually for particularly for EKS, but the concept is the same. If you are using GKE, if you're using other Kubernetes, you can provide. So since most of you are not using Kubernetes today, I will go through it quickly. Okay, so I guess we will have around 25 minutes. During that 25 minutes, we'll go through the context. Why upgrades are number one in the source. Then we will go through what AWS manages for you and what you actually own. We will go through also quickly about EKS go-to-mode, what has changed from that perspective. And then we will go through what breaks. We will take the step by step. I will see every step what breaks, because all of these are predictable and avoidable. And we'll go through like 3 frameworks, 3-layer framework, and safely upgrade on production. Then we're going to be okay, so the number one is today in any workflow for Kubernetes workflow is not spike, not like infrastructure, like failure, anything. Is about planned changes. Why? Because planned changes are something that we change to plan to. We plan to change it, but when we go and do it, something happens in the middle, and then everything goes down. So we take ourselves down because we plan for it, but we don't have an initial process that we should follow. So we are not actually here to tell you avoid upgrade, but we are telling you upgrade, upgrade change with some engineering process.
As long as you guys are using it, okay.
So let's go to
I wanted to
especially for EKS, or focus would be EKS today. So EKS misconception today, people say, okay, EKS is managed, so it's safe to upgrade. But this is actually misleading. AWS doesn't manage everything for you. So the only thing that AWS manages today, the standard cluster, is control plane. Like the API server, the ETCP, and you don't need to worry about this, even if the upgrade of that control plane is taken care by AWS. So you don't have any visibility there. As a notebook, you own that, it's your responsibility. You upgrade the imperfect, the add-on, your responsibility, as well as the workload. In the left side here is actually what exactly AWS managing the standard cluster. Right? You don't have any visibility for the control plane. You cannot SSH. You cannot SSH to the any ETCP VM, and AWS with the actual upgrade, so you will upgrade it using like some technique, but it's not affecting your workload. So it's safe to upgrade. The other side is your responsibility. Also, what can do?
You keep your
add-ons. You are using Kubernetes, and the workload, like typically anything related to your workload is your responsibility to take care of it. Okay, so the ETS go-to-mode is actually has been announced in reInvent 2024, and it's actually shifted all the operation of ETS. So instead of you take care of everything, today Automode is actually taking care of GC2 instances, the BBC CNI, and the add-ons, everything from the infra perspective, they take profit, but you still need to work on your application, your workflow. Like you are using the deployment, using wrong duplication of APIs, you need to take care of all this. So it has been a kind of big shift on how people can actually look into EKS. And yeah, that's the ultimate. Okay, before we go to the upgrade process, we actually need to understand one very important thing when we talk about EKS. EKS is following the upstream from Kubernetes. Kubernetes, we actually release a new version every 4 months, around every 4 months, every quarter, and AWS also follow that. And after 2 days from the upstream, you will see a new EKS upgrade. When the new version is coming, have a 4 months upgrade, 14 months. 14 months as a standard support. So you don't pay for that standard support. You can wait 14 months. And if you didn't upgrade, you will be automatically going to the extended support. Extended support comes with a price. You will pay around $0.60 per hour. So imagine if you have 100 clusters, you're gonna pay around something, 10,000 something.
You have a lot more features.
It's a big cost, and it's actually no need for it, right? After this, after 12 additional months, AWS will force upgrade your cluster. And you don't need to reach to that level, because if they force upgrade your cluster and you have many other things, problems, your cluster only will be kind of down. So you should take care of that route, because it's very critical and very important as well. Okay, so EKS upgrade. It's not one thing actually. It's a couple of things. We consider it 5 or 4 steps, and you need to respect the order. The first one is control plane, where AWS manages that for you. You just trigger, okay, I want to upgrade the control. AWS will make sure that there is no workload that affected. But when we talk about add-on layer, you need to take care of that. You will go through the workflow and workflow and everything. Okay, so all these layers have kind of failure that we need to prevent. We take the first, it's actually 5 layers. Most of the incident and the postmortem that we have, we categorize it as that
When it becomes
5 categories. The first one is API interpretation, CRD and web conditions, networking, CNI, very important thing, the add-ons that we have, and input lifecycle. Which is the most important one, which is API interpretation, which is I call it silent killer. Because you upgrade your cluster, everything works fine, and nothing is affected.
Recently,
But the next deployment, when you deploy, everything is down. You roll back, everything is down because it's using the APIs, right? So all the APIs. So
but I think I should
there actually a couple of incidents happened personally for me, for my team, especially the one with the ingress. This one is Nginx ingress APIs. When they move it from V1 to V1, and we deployed, all the ingress was not performing. Everything went down. Because we didn't expect that. We didn't know. So everything went down. I'm pretty sure many
luckily we met the right time.
Kubernetes have it, but this is the most dangerous one because it's very tight. You upgrade, everything is good until you do the next deployment. When you do the deployment, you cannot even roll back. You have to fix it, and this is a downtime for you. The webhooks, if actually the API interpretation is silent, this one is very loud. it break everything, make everything stack. Theoretically, your cluster will be up and running, but everything is stuck. You cannot do deployment. Any buzzers failed, it can't go through and so on. Yeah, so let's imagine if you kind of doing the upgrade and you have admission webhook bugs that need to be scheduled somewhere. But somehow this bug has been kind of stuck somewhere and you are doing some other deployment. And when the other deployment needs to be scheduled, you need to go through the admission webhook validation that you have. And the API server is trying to call the admission webhook, but it cannot reach out because the bug is already not available for it. During that time, your actual Kubernetes cluster is stuck. So this is kind of very loud, and we need to prevent it. There's a couple of things that you need to do. The first one is the custom edition dispatch. You need actually to have a close look into what you are using. There is also timeout. This is very important part. The default timeout is 10 seconds. The last one is you need to keep monitoring of the failure codes that you have, the validation that you have. All these kind of things you need to audit, make sure that you look into them before you upgrade. Third thing is add-ons. This is where most of the contribution happens. Add-ons in AWS is managed, but you have to actually upgrade it yourself. It's not being upgraded for you. The most important one is the PVC CNI, because this one is assigning the ID for all the ones. If it's actually not matching the version, it will not be your bot will not be able to schedule, and your cluster will be not functioning. And it's very difficult because this thing is actually very hard to define to do the upgrade, because the cluster will be like the zombie cluster. You don't know where things are being, you don't have any visibility unless you look into the AWS Insights. We'll talk about AWS Insights shortly. But yeah, AWS Insights also have a visibility of the add-on mismatch version that you have. Node upgrade. This is real. Most of the folks kind of they think when we upgrade the node, everything will be good, but actually it's not. It's most important thing. And your workload also should be kind of configured in a well, like it should have these all four things. So the problem with the upgrade, the first one is the validation. When you actually running your upgrade, you want to kind of upgrade this node, so all the workload inside this VM basically need to be moved to another one, right? During that trade, the Kubernetes send like safe turn for your buds to stop that bud from receiving traffic. During that time, if your bud cannot actually receive this signal, it will be stuck and it cannot move from this VM. And the VM will be stuck and will not be upgraded. Second thing is bud distribution budget, misconfiguration. People think, okay, if I set maximum unavailable 0 for my deployment, everything will be good. But this is a very misunderstanding. We shouldn't have that in production workload if you have more than one trade. I will tell you why. Yes. And also the long run workloads, workloads like the machine learning or the bugs that doing some job to work. When you upgrade that this bugs are being created, should be moved, right? Your scheduled job will be starting from scratch again. So this is very dangerous to start your upgrade your tool. It should not be during that time. Should be careful because this job will be actually running from scratch again. The most dangerous part is the stateful applications, especially when we talk about the primary contributors or Kafka primary data. It's actually this is the responsibility for the when we talk about the mastering. This when you train one primary, the cluster actually or the database will start to look okay which one needs to be mastered again. And during that time, you will have kind of many other things that been dropped from the request and cannot get something from the database until the database again become in a green state. Okay, so this is all the things, but before we actually finish all the failures that we have, the other thing that is very important as well is version skew. What does it mean? It means like it comes from Kubernetes, but actually AKS. It means like your kubelet should not be less than the control plane version of the API. It's less than one minor version. For example, if your control plane is 1.35, your kubelet cannot be 1.33. It can be 34 or 35. So it cannot go down from 33. Okay? The add-ons, add-ons as well has kind of matrix that's compatible with the Kubernetes version. So if you actually upgraded the Kubernetes and you left your add-on, you will have a zombie cluster. Your actual cluster maybe have missed functions. Okay. So last thing, when you upgrade, whenever like escape one, when you upgrade from 1.31, you need to go through 1.32, then 1.33. You cannot kind of skip that. If you skip that, you will have a lot of problems. Okay. All right. So we talked about many failures. How many failures? In different components. So the good news that if we understand that failures, we can predict it and we can avoid it, right? So today we will go through the EKS upgrade framework, 4-layer, and the order matters. You should follow the order of that EKS upgrade. Most of the things that you need to do is coming from the clustering side, which is the pre-validation. Before you upgrade or you start to plan for upgrade, you should go to the pre-validation steps. EKS clustering side is the one that our entry point. Before that, we did it manual by Cube, No Trouble, or other tool. But your EKS clustering side has all the things that need to be visualized for you. What is the actual API deprecation and other things. Then the next step is control execution. This is the step where you're going to go through the execution of your upgrade. The last one is the observability and rollback. You should keep an eye on our kind of applications and monitor the health of our application during the upgrade. I'll take it step by step. The first one that we need to consider is EKS clustering sites. What does it do for you? It actually EKS clustering sites. It runs automatically every 24 hours, and it's run against everything inside the cluster, like duplicated API usage, the kubelet version is kube compliance, kubectl version, EKS advanced, and the cluster. And if you have any kind of that status, error, warning, passing unknown, today, if you are using AKS cluster and the cluster inside give you error, there is one error, the EKS will force you to not upgrade. So you will not able to upgrade. You have an error, which is a good thing because it's protecting our work. So after we look into the cluster inside, we understand that okay, everything is good. The API duplication scan, we can use like a sub-event for using to no traffic to make sure that our interface is there is no duplication and so on. We look into the add-on compatibility, make sure that the version that we are running or we're gonna upgrade, all the add-ons are compatible with that. We look into the web hub CRD audit, make sure that there is no validating web hub configuration, rotating configuration, which is not aligned. After this, we can kind of do dry run for staging upgrade. So if you have a staging cluster, maybe we can upgrade that in dry run and see what is the outcome from that. Okay, this is all validation. We didn't executing thing. Once we validate, make sure we fix everything that has been coming to us, like the API configuration, the add-on compatibility, and other things. We go through the upgrade, the execution now. What we should execute first is the control plane. Because the control plane, as I did mention, it's managed by AWS and it's once you upgrade it, it will not affect any of your workflow. So you go to trigger that. After triggering the upgrade, it will take around 15 to 25 minutes. After upgrading, you need to validate okay, if everything is going well, validate it using kubectl, if you are able to reach your workload or not, then you run a smoke test, kind of you do deployment. If you do deployment, you make sure that okay, everything is working fine, there is no problem, and then you wait for some time, 30 minutes, you observe. When your observability, make sure that okay, everything is good, there is no issue, and we are aligned with the next step. So what comes next? If our control plane is good, we have done the upgrade, we go through the add-ons. This is the order here matters. Go to add-ons. The first one we do is BBC CNI. Is a very critical part of our EKS cluster because this one is taking care of the assigning the IPs for all the bugs, and it's very critical. Then we go through core DNS. Core DNS is crucial here. Kind of when we upgrade it, we need time to scale it up first, and then we upgrade it to the next version because you don't want your DNS to be unavailable during the upgrade. So you scale it, upgrade it. Then you go to your proxy, and then all your add-ons will be kind of upgraded. If you are using EKS root mode, you don't need to upgrade this. This is managed for you, as well as the control plane is managed for you. Okay, so the next step, which is the most important thing, which is the node rotation. There are actually 4 strategies of node rotation. The first one, which is the easiest one, is doing like the rolling update with configurable max unavailable for your all deployment and EC2. This one is the first simplest one. It's actually recommended, but it's not recommended in all cases. This one is the hardest one. Great. What does it mean? Okay, I have all my EC2 instance on here. I will not upgrade them. I will create another root group, upgrade this root group, and then drain the old one so the new root group will have all the workloads that they have. This is safe, but at some point you will have the same number, you will duplicate the number of EC2 instances. Third one, which is if you are using Carpenter, so you mark the old one as Carpenter drift. When you mark it as a drift, Carpenter will work behind the scene and create a new EC2 instance for you. The old one will be deleted. If you're using AKS auto mode, it's actually, you don't need to do anything. It will be upgraded for you. And the life cycle of any EC2 instance with AKS auto mode is kind of 24 hours, 24 days. So
Is this recording?
there is no
Just
EC2 instance older than 21 days in EKS. So when they schedule a new one, it will be having the new version. And it's managed by EKS. Okay? So if you spend a lot of time, you can start using EKS because it will be upgraded. The thing that I don't like about EKS, they are using the spot instances, which is anytime can go down and they bring another machine stream. Okay, so this is very crucial part is to protect your workload, and this is your responsibility. If you are using auto mode, if you are using standard, they actually respect what you are configuring. The first one is bug description budget, where most of the people here actually define it from, but you should do something like minimum unavailable one or maximum unavailable one.
I think you can just if you know how to connect, you can just do our same thing. So what we have to do is share this one as well.
It means like, okay, you accepting to leave some paths so you can actually go through the upgrade quickly. If you are not doing that and you do a maximum unavailable 0, it means like you don't want any paths to be deleted before it will create. So people can, when you read one EC2 instance, it takes 6 hours, and you complain why it takes 6 hours because you configure that. The readiness probe is very important. Any production workload should have it because Kubernetes cluster is actually assuming your container or your pod are running or healthy once the container starts. So if you don't have readiness probe, which means like you give some time for your container to be up and running and function correct with some health check, real health check endpoint, your Kubernetes cluster will send the traffic directly to this. If you are not doing that, addressable termination, this is very important. The default period is 30 seconds, but we want to increase that maybe like it respect your P99. P99 is your latency. So you need to make sure that the maximum or the highest latency is below this number, right? Respect what you have. The principal lifecycle hog. Most of the team are actually missing that, which is gives the answer to this right. Alright, so observability driven upgrade. In every step, you should look into your observability, you look into your workload, you look into latency, error rate. Saturation means like you look into the CPU, the memory utilization to make sure that there is nothing going on. Okay, so putting all together, so this is kind of the framework that you should follow. The first part is you validate. Today, you don't need to do it manually. You can validate using the cluster insights, scan the workload and so on. You go through the control plane, you upgrade it. You just need to do mock test. You need to wait some time here until you make sure that the cluster is healthy, and then you start to go through next step. Next step, you add-ons. You upgrade the add-ons. Very important part. You don't need to miss it. Then the new rotation, you start to upgrade with your current version. and you have the observe and get, which is telling you actually what you are doing is correct. Okay, TQS, biggest upgrade are ecosystem upgrade is not one single component to be upgraded. To the EKS cluster size, it's well done and free. You need to use any manual approach because before that we did everything with manual. This one introduced in March 2025, which is recently for 1 year. And EKS has only changed the operation model. So if you are actually spending a lot of time to upgrade your Kubernetes cluster, you can switch to Meetup, which is taking a lot of things out of the box. Then zero downtime is engineered, not assumed. So you need to start doing the engineering process for your upgrade and to not make it kind of scripts that you run and you follow. Yeah, that's it, I guess. No? Okay. I forgot to mention something. Sorry. So during that time, all the steps, this observe gate should be kind of pure stop gate. So you do control plane, you observe. Add-ons, you observe. If any fails during that time, you need to kind of stop and investigate and fix. If something you cannot do, start planning for it. And do documentation and work. So the observe here is in all the steps. Once you start step number 2, you need to keep observing. The validation step, when you do the validation, you need to plan also what is your threshold to stop here and to roll back. You need to define all this kind of during the validation, the rolling back strategy, what is the threshold that you should have all that time. Makes sense? That's it, I guess. Any questions?
Anyone have any question? All right, leave it on mic.
My question is simple. Why we are going through all the trouble while we can just start another cluster and migrate the workload? Basically, you're doing a blueprint for the control plane and so the workload together.
Starting a new cluster and moving all your workload in this cluster is hard.
Wow, how hard?
Okay, how hard? How many applications you have in this cluster?
I don't know.
Then you have like 50 workloads that need to be deployed again in this cluster. So 50 pipelines, 50 teams, and all the teams need to be aligned with that. Then you also, I assume you would create the AKS cluster using ISD. You would have a new ISD. Every time you do that, you have the new cluster. Then you start to configure everything again from the pipeline. This pipeline needs to be configured to this AKS cluster. And then once you deploy, you have a new ID for the ingress.
But for me, at least, let's say for example, you have a 50 workload and have 50 different teams. If you create a new cluster from scratch, where you can confirm that all the control plane and all the worker node and everything is basically the latest one. So you can basically migrate one workload at a time, maybe every 2 days, one workload, every 2 days, one workload, and you basically still maintaining the old one at there until you migrate everything and then you destroy the old cluster.
It's a good strategy. It is a lot of problems. If you imagine this, like, okay, I have a database running this cluster. I have data inside this cluster, right? Then I need to migrate this data to another cluster. The purpose is for upgrading the cluster, which is in the full of processes, right?
Okay.
So we are adding a lot of functions on them. This workload is not a static workload, right? They need to maintain some data. So during that transition, you're gonna lose the data run, right? You need to stop that first downtime, and then you go to the other side, will be up and run. You cannot avoid downtime in this case. All of the process that we are following today is the main purpose for it is to upgrade without downtime. Without incidents.
Next question. What if after you do the upgrade and then something wrong, but you cannot roll back? For example, on the control plane side.
Control plane,
Yeah.
is managed by the
Yeah, I know, but you upgrade it and then it says it's failed, but you want to roll it back, but you cannot. Yeah, I've seen that cases before.
control plane. But if you are upgrading your workload, control plane, then something happened, you need to reach out to support.
Okay.
You don't have any visibility.
Okay, yeah, yeah.
It's the whole thing, but it gets like it's controlled and managed.
Correct.
Right? And if something happens there, of course your workload is still running. It's not affected, but you are not able to deploy. You are not able to do anything because you cannot reach it to the cluster. Everything reaches to the cluster. So
Yeah.
they control it, right? So yeah, so you reach out to support. Then they say,
Okay. Thank you.
Hi, I have another question. So have you there's actually two questions. So if let's say we are using the Terraform module, AKS module, it upgrades the control plane and the node at the same time. So given that we want to maintain the current workflow, which is fully via Terraform, how would you suggest us to do it?
that's step by step approach. The control plane should go first after you upgrade.
Yes, but when you change the version in the Terraform EKS module, it upgrades the control plane first, then it automatically upgrades the nodes. So is there any node processes?
Okay, so when you are if you are mentioning like okay, I updated my Terraform, I run my Terraform, it triggers the control plane run first, after this it triggers the workload to run, right? I don't have any process for that, but usually for the step upgrade, we upgrade manually and we sync with the Terraform. So in this case, you step by step for the production or for the other workload or not critical workload, you can go to Terraform, it goes up to you. But we want to be safe, right? So we upgrade the control plane, wait, make sure all is good after our validation. Then we upgrade the add-ons, make sure all is good. Then we upgrade the
Yeah. Another question is, have you like encountered where you want to upgrade stuff that is managed, let's say by EKS auto mode, but your pod disruption budget does not allow it. So what will happen?
One last. I'll let him finish. After that, we're gonna move.
okay. If you are using auto mode, actually auto mode cluster is building VM or EC2 instances out of the So I didn't face any problem with pod disruption.
Like for example, you create only one pod for that particular deployment, and then your pod disruption budget says minimum one pod. So what happens?
minimum one value, but the maximum unavailable is 0. It's like we need to maintain this. When you upgrade, it will actually create an EC2 instance, moving this to that, then one. How it works. This is actually because EKS put mode is working very closely with the budget, with the termination, graceful termination, and the readiness. All this kind of configuration, the full configuration, you must have to make sure the EO2 mode can upgrade your code in the same place. But of course, you don't need to have the maximum unavailable 0 for workloads and 100 bucks. Because this takes 5 to yeah, thank you guys so much.
You sure?
All right, thank you guys. Hope you guys have had a very good session.
Is that the top?
Did you guys understand? Or is it a question answer of the head? I know you said Wednesday. Wednesday night. Thank God it's not Friday night. Right. But then yeah, without further ado, let's call upon the next speaker. Next speaker would be Shah Hassan. So he's head of engineering at Fintech. All right. So let's give him a round of applause.
Hello. Hi guys. Typical boring excuse, technical problem. Thank you for staying up. We're supposed to be here at 9, right? So I got 9 minutes 30 seconds to finish this. Thank you. Okay, cool. So my name is Shah. The higher title that I hold in my daily life is father of 3. Bookkeeper. I buy book, but put it on the shelf. Part-time gardener. Oh yeah, father of the husband of 1, of course. I'm currently working with engineering team in one of the Fintech company based in Plaza Central. The thing that I'm going to share today is running financial ecosystem or payment platform, multi-region. All right. So in the next 10 or maybe 15 minutes, I would like to share how we design this multi-region system. And out of many use cases, we use migration as one of the use case. All right. First thing first, why engineering team across the world have been busy talking and working on this multi-region. Many reasons. Migration, failure, isolation, performance, regulatory, scalability, and cost. Example, failure of isolation. Because today, organized by Docker and SRE, so we declare Docker as the main star. Okay, so imagine you are ordering food using a Grab application. Raining, one of your rider cancel, so your package will be picked up by the other rider. What matter for you? The package will reach your door. So take that analogy as the multi-region. In the world of Docker image, doesn't matter which rider, you don't care. Male, female, someone in between of that. What matter for you is that Docker image delivered to the target environment and your audience, your consumer, can get benefit of it. So that is about multi-region. Okay. Yeah, for those who are working in financial sector, most likely very familiar with the first part. In the previous slide, I did mention multi-region also motivated by audit compliance or regulatory framework. We are living in Malaysia. We need to comply with many audit regimes. BNM, RMIT, BNM, cross-border initiative, PDPA, PCI DSS, BSA, FSA, and everything under the sun. The similarity between of these different audit compliance and regulatory regime, you will find paragraph there where they mention stand-in processing, or in a technical word, we call it as backup region or disaster recovery. Meaning to say, one guy go down, another guy stand by for you to deliver that thing. So these different framework talking about that. Meaning to say, if you are not dealing with downtime of any cloud service provider, most likely you have to deal with this, or you have to deal with this performance issue. So different organization, different engineering team are dealing with a different motivation. Okay. The strategy that we use in our company recently, based on this 4 pillars, when we are working on the multi-region, number one artifact. Number 2, we separate pipeline, which I refer to as pipelines. Number 3, we isolate runtime. And number 4, independent control plane. Okay. We do share component or element, but we share only what is safe to share. So here, the title of this slide, I'm talking about decouple everything that matter. But actually, at the first level, when it comes to Docker image itself, you only click one. Okay. And about the pipeline, I think majority of the team, engineering, DevOps, whatnot, you guys do have everything pipeline that responsible to do things for that particular service. So when we start to do multi-region, this is not a Bible, but maybe the tips and tricks. We don't disturb the existing pipeline, but we build a new one beside the existing one. Thinking about you are working on the highway. Imagine you do have a live traffic on that particular highway where you need to extend the capability to deliver the user of the traffic with the new destination. You go and stop that highway and put that highway under construction because you will stop all the traffic vehicle and whatnot. That is where your package will be problematic. So what we do is we extend the highway, build the highway beside. We need to say you play safe. The traffic will still flow on the highway, but you build another one. That is what happened to the pipeline. Okay. All right. Okay. So the next one, a little bit deeper into the architecture. Nothing fancy here. The architecture or design that you see here, you already see somewhere else. So on the left side, we do have a group of people called engineers and developers. They don't have anything else in their life. They push, merge, and battle among themselves. Hey, why you write this variable this way? Hey, you got a merge conflict one. That's what they do. Okay, they are all working against one service repo, and in our working environment, depend on how you guys design, but we design this way. We do have a DevOps repo based on the region. Okay, we can imagine the folder of file structure that we do have one repo for this region 1, and another one is DevOps repo for this region 2, and the next region. Okay, every time our pipeline is triggered based on a certain event activity, we will cook based on the job and stages, and then we will craft that particular manifest to be located in the specific repo. And of course, on the left side, based on the region, we do have a dedicated set of all the different technology stack and components that must work together. We do have feature flag, we have Argo CD, we do have image registry, ECR, and we are using secret manager and of course yes. Right. So when we are working on the multi-region, we replicate whatever tool and component that we have on the other region. There is pro and con of using this approach. There are teams that only use a single control plane. If you remember the talk delivered by our friend just now, from a different perspective, in that use case also, he suggested something about control plane, right? Okay. Again, back to the definition. You see here, the architecture that we have here pretty much defined by the definition of the multi-region. So best thing for us to do is we go back and ask the company, CEO, CFO, CTO, CTO, and what is the definition of the multi-region? Because it can be defined differently. The most pure definition of multi-region, everything split, differentiate by the region. Because the main goal is to have region independence. If we define the multi-region only applicable at the EKS level, that is where your microservice operating, but the source of truth like image registry, ECR, still rely on the region. That region go down. So again, depend on the definition. There is an ongoing infinity debate about this. that company claim they are doing multi-region. This company go in and say, hey, you talking suck. This is not multi-region because your ECR still under this region. No, depend on the region. Okay. All right. About the artifact, we built once region where image push to region based ECR and save image everywhere. Sounds typical, right? Because that's the purpose of Docker. A little bit more deep about the way we do it. We are writing C# and we use .NET. So at the code level, related to the stages, we do have these typical stages like build, publish, publish. We build once. In order for us to build once, we make the YAML file or engine that is possible to code the image of the Docker to be what we call as region aware. Meaning to say you have to speak that file, that single file that can facilitate a different need by different region. I'm talking about variable. You can fit in that variable. So that is how we achieve the strategy of build once. And the next stage depend on how we define multi-region. We trigger a different publish stage. Again, depend on how we architect and design the system, pro and con. Okay, and then this different publish stage, of course, pushing to a different ECR region. One ECR located at region A, another ECR located at region B. If you have 4, 5, 6 ECR, then do the same. Okay. Okay, cool. Anyone watch movie here? I think. Okay, one thing to do them all. And the darkness bind them. This is specifically on the dot spot on with Docker situation. Gandalf don't do that. Gandalf don't go. But Gandalf know about this principle and fundamental understanding. Okay, so we build one image, but that image cannot work without the code that we have to create, which is the variable, the 21. So in the Kubernetes punya environment, run import, right? That is where we inject the variable during the right time. So that is fine. We bind that so we waste the darkness of the right. Okay, cool. About the pipeline, this is another typical one. Okay. In future, if you want to you might have. But what we did that day, we do have we have monorepo and polyrepo. That's a typical code repo strategy. Almost every right? Polyrepo, one specific project for that one repo. Monorepo, we have one big parent project, but inside the chart repo that independent each other. So for that, when we start to do multi-region, we create a specific GitLab CIM for that particular region. You can imagine that GitLab environment. You will see .GitLab the region 1 here, and another one is region 2, another one is region 3. So all these different YAML will be triggered by the parent YAML. Meaning to say, by that single event initiated by developer, for example, merge request. If the logic of your pipeline is based on that, so this GitLab YAML will trigger all the chart YAML. That is how you can have dual or multi pipeline. And of course, you will need more. Your CFO and will give you. Okay, because that different pipeline will be picked up by the different GitLab run. Depend on how you design your system. Either you are using GitLab shared runner, where you have to buy the compute links, or you are hosting the running inside of EC2 team, sucking the resource of this. Okay, so during this period, right, doesn't matter what kind of use cases, your invoice will be like for triple. Okay. So good luck with that. Another thing is runtime config. This is the thing that I talk about Gandalf input learning, where we externalize all the value needed by that service or image in order for it or for them to run. For example, we externalize this thing. Okay, so this is another sinful thing that engineers do. They hard code value. Right? We hard code value, not they. We hard code value. There are times where we decided ourselves, hey, let's do this. Let's do it. So we hard code, right? We hard code. So of course it's a poor practice. But in a bigger event and bigger use case, we will hit a bottleneck where we have to region aware. So first thing first, we externalize that value. So that Docker image can become the one thing that rule them all. We need to say, once we externalize that value, we inject the Docker image based on the region environment that we run. That's the recipe. Okay. Typical things in whatever programming step when you are running in Docker or Kubernetes, before diving in there, config map is not sensitive. XML does not belong to .NET punya approach. External secret is the bridge for the secret manager. This guy will pass here and this guy will talk here. So it is more sensitive. But in this case also you will have a aha moment. Okay, what is the put this non-sensitive secret manager and the same time sensitive config map.
Outside.
So this is under the config part of the
I might have to.
control plane. When we start to build the multi-region, we originally have one that watching that dedicated single standalone DevOps repo. Once we want to replicate the region, we go and provision another repository that's sitting in another. So meaning to say, we do have two guys that watching different DevOps repo. Any changes detected here, this guy will sync to EKS and EKS will go and pick up the image. Yeah. A little bit quiz. So inside the EKS, which component is responsible for the image? Kubelet. So kubelet once EKS punya environment receive the new request, the whole kubelet will go and pick up. So this is how the multi-region works. Okay, cool. Another part of the multi-region we do have is request management tool and customize. Different teams use different stack. Have Taiwan, but in our case use customize. Docker gives us container image, but customize is a complementary to give the deployment shape.
Like 5 minutes.
We are not only dealing with multi-region. Why we have about we have and what in our case, what we all for development during December production. But for the other networks, maybe you have to find deadline. So that is where customers become ideal. Okay. Okay, cool. Security is quite simple. We use DMS to encrypt the information address. Towards the end, in terms of multi-region, it's not everything about migration, like I said just now.
1, 2, 3,
there are
4,
different phases, even
5.
for this multi-region. You only will keep the stage once you hit the stage. And to say there is a major requirement for you to do that. Like talking about in DR, regional performance optimization. Okay, another 5 minutes. Reality check. Sounds fancy, but it's not free. Like I mentioned just now, your CFO will give you because it's multi-region. We have to pay for another region, and we have to deal with different others. Some building resources for the cheaper inflation, but for the other region. So another thing is operational complexity. But all these things, right? It's a very juicy thing for engineers. To cut things short, your CTA today came to mention, everyone, let's go back, find our use case, and get approval, making a budget for us to kick off our multi-region initiative tomorrow. You think yourself up. Yeah, you can yeah. You can sell this thing. I'm giving you tips. I'm telling I know this. Okay, but remove my name. The motivation. This one. Find your use case. You can talk about value explanation. Tomorrow you go and speak to your CTO. You know, our customer will understand in Malaysia, but we have to create another region in Singapore. Yes. Anytime Malaysia can be attacked, but
Yeah, that's
and the whole data center. So you talk about value explanation. If you are playing financial and fintech, you talk about the DevOps. Tomorrow they will come knocking your door die because you don't have money. So that's it for tonight, guys. Thank you.
All right. Cool. Are you guys excited for the next thing? The next big thing. Oh, actually. So all right. So I think without further ado, let's get into our quiz session. Okay. And the rules and regulations, I'll let Amit to actually take over that. Okay. Yeah, the rules and regulations basically means don't copy each other.
Which old is it?
All right. So we'll be gifting three. We'll basically be having three prizes. First prize will have an AirPods by Cast AI. Second, third, you guys know the normal drill. The usual drill is Dr. Swags, and that is what happens. Maybe we can, if we are very generous, we will also give Dr. Swags for the first winner as well. The first prize winner. The first prize winner is too generous, means pretty much we are too generous to give him an AirPod.
While you scan the QR code, you ID the email ID. Yes, equal email and full name, please. I promise you that. Have 6 active participants now. Everyone got the code? Can I jump to the quiz? Anyone needs a minute? 21 participants now. $33 now, 34. Let's give it last 30 seconds before we start the quiz. Anyone who needs some more time, can you raise hands, please? Anyone who needs time? No? Then we start. Okay, some of the questions, the fastest to answer gets more points, but those questions will clearly say fastest to answer gets more points. Before the question, there will be a prompt. First few questions, every right answer gets the full points. So be careful, please. I have 42 people on this now. Can we start?
All correct answer give you next point. What does SRE stand for? Someone ready? Okay, what other words in? Let's see. What are back next to the person who voted. Honestly, let's see who is. I think many of you would be on the leaderboard. Whoever got it right. All right, next one. Question 2. Answer quickly to get more points. This my presentation. You will see. Ooh, thank you. Most of you were attended. Okay, let's see who's on the leaderboard after this question. All correct answer give you max points. Question number 3 on your screen. One person here to go. Okay. 31 right answer. Let's look at the leaderboard now. I'll not ask anything. Let's look at the next question. Question number 4. Answer quickly to get more points. That's very nice. Question number 6, and I'll have the leaderboard after this. Which of these is not a key area? Not a key area. Okay. Everyone has voted. You're smart audience.
I'm smart.
Okay, let's look at the leaderboard. Wow. 1, 2, 3 are super heroes. You're super close. Over you. Okay, 2 more questions before we finish. Answer quickly
Everyone, almost everyone. Okay. I'm not sure leaderboard now. We'll wait for the final question. This is the final question, guys. Focus, please. Answer quickly to get more points. Wow. I have to admit, this is one of the best videos I've seen. Wow. Take it back, take it back. Number 2 is formed with number 3 is
Okay, guys. As promised, we're gonna get a few more swags for number 2, number 3, and a few more people. Okay. So can I call upon Kathy, Dr. Centipede, and Montana? Yeah, please. So, yeah. All three of you guys will have something in common. And then we will, then Zidan will give you guys the brain score. But for now, let's handle the topic. Let's get a picture first.